Hello, friends, and welcome to my YouTube channel Electrical Hub. Here we are going to discuss about the boiler efficiency. It is very important to know and evaluate the boiler efficiency while working in the power plant. So, we will discuss in step by step how to calculate the boiler efficiency. But before going to the efficiency of the boiler, we will just go through small points about the boiler. What is a boiler? It is an enclosed vessel where heat is to be transferred into water until it becomes heated water or steam, right? So heat is transferred by three means, by any of the three means like conduction, convection, and the radiation. But whether any enclosed vessel where the heat is transferred by the radiation, convection, or conduction is known as a boiler? No. There are certain parameters or guidelines given by the boiler standard in India. So, what is the standard? First, is capacity should be more than 35 liter. Second, its pressure should be more than 1 kg per square centimeter, and the water must be heated above 100 degrees centigrade. So these three are the conditions to be fulfilled to be known as the boiler. So how we can evaluate the performance of the boiler in day to day? We cannot go on calculating everything every day. So to know the boiler performance in the day to day life, the simplest indicator is the evaporation ratio. What is evaporation ratio? It is the steam to the fuel ratio. It indicates the quality of combustion, condition of the heat transfer area, and the quality of the operation and maintenance too. Now let's move on to the our main topic, that is the calculation of the efficiency of the boiler. So boiler efficiency can be evaluated by the two methods. One is the indirect method and other is the direct method. Indirect method is used generally to for the exact calculation of the boiler efficiency, and the direct method is generally used in the day-to-day life, means in the day-to-day operation of the boiler. So, indirect method goes through a long process, while the direct method is a very easiest way to calculate the efficiency of the boiler. We will also discuss about the direct method, but first we will discuss about the indirect method. There is only a slight difference between the result if we calculate by the indirect method and by the direct method. For example, if we calculate by the indirect method, the efficiency will be 80.7%. Then, by calculating by the direct method, we can maybe 80% or 81%, like that. There will be only a 0.7% or something like that difference. So, how we can calculate the efficiency of the boiler by the indirect method? There are four steps to evaluate boiler efficiency by indirect method. First is to calculate the theoretical air requirement. Second is to find the excess air. Step 3 is to find the actual mass of the dry flue gas. And fourth is to find all the losses. So we will discuss step each of the step, and will come to conclude the boiler efficiency by indirect method. So, in the step 1, there is a requirement to measure the theoretical yield requirement. So, there is a direct formula for the calculation of the theoretical yield requirement, that is 11.6 C plus 34.8 into S2 minus O2 by 8 plus 4.35 into S by 100, where C is the carbon, H is the hydrogen, O is the oxygen, and S is the sulfur contained in the fuel analysis. Remember, it is in the fuel analysis. So, you can note down the formula and we will move to the next step. Now, the step 2. Step 2 is the excess air requirement. In the excess air requirement, we need to calculate the percentage of excess air. How? Through O2 analysis in the flue gas. So, How the O2 analysis can be done? So O2 percentage in the flue gas by 21 minus O2 percentage of the flue gas into 100 is equal to X percent. So that X percent is the excess amount of the year behind the theoretical year requirement. So from the first theoretical year requirement, we can calculate the excess year requirement. So step 3 is the mass of the dry flue gas. So actual mass of the dry flue gas is equal to mass of CO2 plus NO2 plus SO2 in the flue gas plus mass of N2 content in the fuel plus mass of N2 in the combustion air. So that is the actual mass of the dry flue gas. Now we will go to the final step. The final step is to calculate all the losses. First is the percentage of heat loss in the dry flue gas. Second is the percentage of the heat loss due to the formation of water from the S2 in the fuel, percentage of heat loss due to the moisture in the fuel, percentage of heat loss due to the moisture in the air, percentage of the heat loss due to partial conversion of C to CO, and the heat loss due to the radiation and the convection, and finally the heat loss due to the unburnt in the fly gas. So we will have to evaluate all the seven type of the losses in the indirect method. So we will evaluate it step by step. First is the percentage of the heat loss in the dry flue gas, that is m into Cp into Tf minus Ta by GCV of the fuel into 100. What is m? M is the actual mass of the dry flue gas. What we have concluded in the step 3. Now Cp is the specific heat of the flue gas in kilocalorie per kg degree centigrade, that is exactly 0.24, and Tf is the average flue gas temperature and Ta is the ambient temperature. So we can conclude the heat loss in the dry flue gas through the this formula. Second is the percentage of the heat lost due to the formation of water from S2 in the fuel. That is 9 into S2 into 584 plus Cp into Tf minus Ta by GCV of the fuel. So H, here we know the hydrogen in the fuel analysis, Cp is the specific heat, Tf is the average flue gas temperature, Ta is the ambient temperature, and 584 is the latent heat of the water. Similarly, the percentage of the heat loss due to the moisture in the fuel is m into 584 plus Cp into Tf minus Ta by GCV of the fuel, where m is the moisture in the fuel analysis, Cp is the specific heat, Tf is the average flue gas temperature, and Ta is the ambient temperature. So friends, if you are liking the video, please press the like button. Also share it to your friends and subscribe to my channel for such an informative video. Now moving to the next point, percentage of the heat loss due to the moisture in the air. So AAS, what is AAS? That is the total amount of the air supplied, means theoretical air requirement plus the excess air. So total amount of the air supplied into humidity of the air to simply the specific heat. Tf is the average flue gas temperature, Ta is the ambient temperature, and GCB of the fuel. Moving to the next is the percentage of the heat loss due to the partial conversion of C to CO. So CO we will get from the fuel gas analysis and C we will get in the fuel analysis. The formula is percentage of CO into C into 5654 divided by percentage of CO plus percentage of CO2 into GCV of the fuel multiplied by 100. So percentage of the heat loss due to the unburnt in the fly ash is the heat loss due to the unburnt in the fly ash by GCV of the coal into 100. And finally, the heat loss due to the radiation and the convection is taken as the 1% because it is quite difficult to calculate. So generally we take it as a 1%. So after evaluating all the losses, you can easily calculate the boiler efficiency. Just add all the losses and subtract it from the 100. So that the value is the actual efficiency of the boiler. But we can do it in a very easy manner also in the day-to-day activities. So we will go by direct method in the day-to-day activities. So how we can calculate the boiler efficiency by direct method? There will only be a slight difference between the calculation by the indirect method and by the direct method. If you want to calculate the exact value, it is by the indirect method, and if you want to do uh, very close value, then you can go by the direct method. First, here the formula is Q into Hg minus Hf by Q into GCV of the fuel into 100. So Q is the quantity of the steam generated per hour. Q is the quantity of the fuel used to generate that steam. Hg is the enthalpy of the steam generated in the kilocalorie per kg, and Hf is the enthalpy of the feed water in kilocalorie per kg. So if you will apply this formula, then you can easily calculate the boiler efficiency by direct method in day-to-day activities. Thank you, friends, for watching my video. Please like, share, and subscribe if you have really liked the information. And if it is informative to you, please share it to your friends. Thank you. Stay safe.